Before we start solving any problem in mechanics, we need is one basic tool, and that is a way to describe where an object is, and that's what coordinate system does. It helps us give mathematical language to define its position, motion and direction. Every topic you learn in this mechanics start with this basic. And today in this video we are gonna start with 2D coordinate system, that is Cartesian coordinate system and polar coordinate system. So now let's start with Cartesian coordinate system, the one we have been learning since school. It's simple. X-axis and y-axis simply perpendicular to each other and meeting at a point O, that is origin. Suppose we take any point suppose we take a point P, that is to define a point P, it is written as x comma y, that is x unit from y-axis and y unit from x-axis. So for a position vector it is written as xi plus yj, and suppose the object is moving, it's changing its position with respect to time, that is velocity. So for velocity we will differentiate it with respect to time. So for velocity it's gonna be x dot I cap plus y dot j cap. What dot represents here? Differentiation with respect to time. And for acceleration it is written as x dot dot I cap plus y dot dot j cap, that is double differentiation with respect to time. So that's all about Cartesian coordinate system. In mechanics, when a particle is moving in a plane, we describe its position using coordinates. The Cartesian coordinate system works fine when the particle is moving in a straight line or along the fixed direction. But when the particle is moving along the circular, using the rectangular coordinates gets messy. So here the term called polar coordinates is introduced. So polar coordinates, the point P, it is given as r comma theta cap. So what r is? Two terms, r and theta. So what r is? R is the distance of a point P from origin, and what theta is? The angle of a point P from x-axis. So in polar coordinate system, this is x cap, this is y cap, and this is r cap, and this is the angle theta. Angle theta is always perpendicular to the r cap. So for the vector r, we are going to write it as r cos theta I cap plus r sin theta j cap. It's the basic, we all know it. And r cap is equal to cos theta I cap plus sin theta j cap, and theta cap is equal to minus sin theta I cap plus cos theta j cap. So simple. So for the position vector in polar coordinate system, it is given as r cap. And for the velocity is the differentiation of position with respect to time. So for velocity, the formula is r dot r cap plus r theta dot theta cap. And for acceleration, it's a bit complex, but it is r dot dot minus r theta dot square r cap plus r theta dot dot plus 2r dot theta cap.